Welcome everyone. It's great to be here as always, and this is kind of, I guess, an overview of what we've been up to in area 1, which is the policy research thrust area, and I'll do this together with Tamara Patton, who's one of our PhD students. So I've used this slide many times, and I'll use it one more time, I guess, to kind of set the stage that there are two ways of approaching the verification problem. A technology-focused approach and a mission-focused approach, top-down, bottom-up, and I think it's fair to say that CVT kind of seeks to combine both. So most of the thrust areas are kind of technology-focused, but this one, policy research thrust area 1, we consider a treaty-enabling approach. So ultimately we are interested in verifying treaties and agreements, and so what we are trying to accomplish in this area is to, anticipate and look where the gaps are and how we can effectively close them, and hopefully we can, along the way, also support and guide some of the developments that are going on in the other areas. So what are the relevant arms control treaties and agreements? Again, I've shown this several times before, and you know who they are. It's the NPT, the CTBT, the FMCT, if we start negotiating it one day, and then what I call next generation nuclear disarmament treaties. This year I've added one more thing to this list because it's actually quite important, and I call it here bilateral or multilateral non-proliferation and arms control agreements. And in this area I just want to highlight two of them. One is the JCPOA, the agreement between the P5+1, the Iran agreement, which of course was one of the highlights last year, July 2015. I'm not sure if you can read this here. The front page of the New York Times said, "Accord is based on verification, not trust," Obama says. So verification, of course, is very much at the heart of this agreement, and indeed it has various kind of innovative new ideas and concepts, and I list just a few of them here: containment and surveillance of centrifuge production, online enrichment monitoring, and monitoring of war concentrate production and procurement channels. So there are lots of new ideas that were actually built into the JCPOA, and it's something we're following and we'll be evaluating along the way. I will say, however, that the JCPOA also has a note saying that these provisions should not be considered setting precedents for any other state. So, but still, it's going to be interesting to see how this plays out. So this is good news. Unfortunately, there's been a lot of bad news, quite frankly, over the last year or so, as you all know. I mean, things could go somewhat better between the US and Russia in particular. And just to give one example, the PMDA, the Plutonium Management Disposition Agreement, which envisions a disposition of 34 tons of weapons plutonium on each side, was recently where Russia decided to suspend the agreement, mostly as a political, I guess, signal, because it's not quite happy with how the relationships are with the U.S. It's not terminated, but currently suspended. But again, the agreement actually does include detailed verification provisions to make sure that the plutonium is actually disposed of. So we haven't gotten to that point, but there's still hope that one day we can actually work toward implementing and verifying this agreement. Now, typically at this point, what I do is I walk us through the different treaties, NPT, FMCT, or CTBT, FMCT, and so on. What's new? There hasn't been much new to report over the past year, and maybe I should conclude at this point. But I will actually try and do it somewhat differently in a few minutes and say, so what can we do in the meantime while we're not making progress on a very fast pace. But before I get to that point, I wanted to emphasize or kind of highlight very quickly something else that we've been working on, and we've shown this at the UITI meeting in June, so I tried to be very quick here. For those of you who've seen it already, We call it the Mapping Nuclear Verification Project, kind of trying to put CVT projects on the map, so to speak. This website, unfortunately, I wish I could say it's live now, but it's not. We're not quite there yet. We're working with a professional web development company in Philadelphia, so that's going to happen early next year, maybe even very late this year. We call it NU. It's a fictional nuclear weapon state. The URL will be verification.nu, and it's essentially kind of a tool. We envision it as a tool to kind of understand the landscape, the verification landscape, and see how things fit together. So this is a weapon state with different the different sectors, fissile material production, assembly, maintenance, deployment, storage, and so on. Of course, we already do have some experience with verifying treaties, and we try to kind of highlight them here on this stand-in with different colors. And then eventually what we want to accomplish, of course, is we want to kind of understand how would you be non-compliant with the treaty. So how would you actually violate the treaty? And this is indicated here with these red arrows. And the idea is, okay, how can we get rid of these arrows one at a time, if you will, using different concepts and technologies. So what this will then allow us, we can look at this, at this map. We can locate, hopefully, where our projects are, and I hope I give everyone the credit here. I try to kind of sort things accordingly, but so you can see who's working on what. All the 12 universities. We could also add the labs, I guess, but they're also working on every possible aspect. And then if you're really interested in, understanding what specifically is Michigan doing on a certain subject, you can kind of zoom in and kind of find out about specific technologies. So that's coming. And I guess we'll send around a note, and of course we hope to be able to work with you and with everyone. We were hoping to work with Los Alamos actually to kind of make sure everyone is kind of agrees that this is a sensible kind of thing to frame this problem. Okay, so as I mentioned, I won't go through the usual kind of list of treaties. And because there hasn't been, in Geneva, hasn't been much progress, CTBT ratification hasn't happened either, and so on. But instead I wanted to ask, how can we add new dimensions, if you will, to our verification research? How can we maximize the impact of our work? And I just try to throw out 3 ideas, and we'll say a few words about each one of them. And the last one is then eventually the segue into Tamara's part of this talk. So let me just start real quick. Enabling transparency without intrusiveness. If we look at transparency is a good thing, I guess, if you worry about verification. But the P5 weapon states, the level of transparency is very uneven. So if this is a scorecard that we put together, and I guess you can see the colors. The US has been actually taking the lead on this, especially in the 90s with the transparency and openness initiatives. So shown here are transparency levels with regard to warheads and fissile material stockpiles. So there's a lot of green, some green. And on the other side you have, let's say, China, which has been quite intransparent with regard to its stockpiles. For good reasons, I would argue. I mean, there are reasons why China does not want to be more transparent right now. But you also have countries like, Russia is also quite intransparent about its inventories. And let's just say I wouldn't hold my breath, until this changing. It's not imminent, I guess, that most of these weapon states will have new transparency initiatives anytime soon. So the question is, in the meantime, what can we do? If somehow we have to work around that problem that there's limited transparency. So here are a few suggestions. One is, of course, maybe we don't even need transparency. We do the inspection and verification from a distance, standoff detection or wide area monitoring. And of course, we have a whole research thrust area working on this, so I won't go into great detail here. We have a talk tomorrow. There is a CTBT, of course, which uses it extensively. We have lots of projects on radionuclide signatures, atmospheric transport modeling, emission source terms, advanced detector technologies, which are all relevant for NPT, FMCT, and CTBT verification. Perhaps more, more interesting is the second part here, where we'd like to ask, and can we kind of modify existing approaches and technologies for on-site inspections to make them less intrusive? And again, I put together a few ideas. Unattended inspection systems could be one of them, online enrichment monitors, for example. Information barriers, we hear a little bit more about this during this meeting. They're typically used for or envisioned for warhead confirmation inspections. But there may be broader applications for information barriers, perhaps even for MPT or FMCT inspections. Just to give one example, Dave Weehee and company here in Michigan are working on a analog ADC, analog to digital signal converter, on a hardware level that would kind of lose irrelevant or sensitive information very early on a hardware level to kind of protect it. So I think information barriers are a very interesting kind of area of research. And then finally, this is a plug for the student talk later this morning. Sebastian, Philippe, and a few others at Princeton and elsewhere, he really had the idea of using what is called virtual proofs of reality. Can you actually have inspections without even going to the place that you're inspecting? So that's coming up in a moment. We see how I'm doing. Second, I'll be very quick here because I want to give Tamara enough time. Using historic data and records to validate modern technologies and concepts. So essentially the story is very simple, I believe. We have an incredibly rich kind of nuclear history with plenty of data. Most of the data is actually from the past fissile material production, nuclear weapon tests, what have you. But in the meantime, we advanced our technology so much that we can detect much more sophisticated things. But we often cannot validate our technologies because no one except North Korea is testing. So Paul Richards, I guess, is proposing to, for example, rescue some millions of old seismogram data sets to kind of validate modern technologies, especially, I guess, algorithms. And I'll talk more about this later. Final point before I hand it over, leveraging the wisdom of the crowd. I'm already getting signals, which makes me really nervous. We have sensors everywhere, especially in our phones, of course, and there are exciting developments in open source software and hardware. And again, I think we can take a real advantage of this. Milton Garces will talk about, I think, his infrasound app, which you can download onto your phone. And I believe there's plenty of computing platforms out there, and there have been kind of ideas, especially Livermore and Sandia, to actually agree on a common computing platform for trusted treaty verification applications. It would be fantastic if we kind of had such a platform and could jointly develop our tools. And with that, I wanted to hand over to Tamara, who's going to talk about VR for nuclear verification, which again I would consider leveraging the wisdom of the crowd here.
Hey, thanks. Thanks for the opportunity to update you on our work on virtual reality and tell you a little bit about the demo that you can come and check out over lunch. Before I begin, just a quick recap on the motivation for this work stream. We've learned a great deal about how to design and optimize verification systems at the facility level from live exercises like the UK-Norway initiative or from the UK-US cooperation. But because of the relatively large amount of resources required to conduct these exercises and the security risks involved in bringing foreign personnel into sensitive facilities, they've not been able to occur often. So that's one motivation for continuing and expanding the work of live exercises in virtual reality, where you have a greater degree of flexibility to do things like quickly adjust architecture and technologies. You have the important benefit of accessibility to avoid costly and potentially risky disruptions to real facilities. And of course, there's the added benefit of being able to better collaborate by having this realistic and common visual reference. VR basically gives us a way to not just run like a single verification exercise, but rather to design and test a much wider variety of verification approaches, both at a broad enterprise level and at this detailed facility level, and also try out different combinations of technologies. Whoa, okay, I only have 2 minutes. I'm going to speed this up a lot. One thing, virtual reality, the full motion aspect of it really takes this to a whole nother level of being able to walk around. Instead of looking at the problem on a piece of paper, you're actually in it. If you don't believe us on this notion of the brain doesn't much care if the experience is real or virtual, there's this plank demo that you're also welcome to try out, where you'll see that people react very instinctively to these virtual environments in terms of sort of the way you would respond to normal environments and this height factor. The system we're working with is Oculus Rift combined with motion trackers for 50 square meters of space. This is possible to expand up to a much larger scale with additional players, and that's our goal, is to be able to do this with multiplayer exercises. While you're in the virtual environment, it's also possible to transport yourself to different parts of the facility. So even though you may be constrained by physical space, your virtual space is always going to be essentially limitless. To better facilitate this, we're working on building a mini-map feature. I can tell you about another time. In terms of applications, a wide variety. Again, no time to get into it here, but across these areas of design, collaboration, and simulation. As a start, we've begun developing some case studies to demonstrate how you could use FMVR to design and examine a verification approach. This illustrates our strategy for combining FMVR with the new mapping project that Alex said, so that you're looking both at a broad level, but also drilling down into the facilities as well, so that everything is coherent. I think that's I'm out of time, yeah, we'll leave it there and come out and check out our demo if you want to hear more. Thank you.
In the case of highly enriched uranium, non-weapons use of highly enriched uranium, it came up in connection with our negotiations with Iran at sort of the peak of the crisis.